Today we're going to be working on the use of the derivative rules in finding the derivative of some special functions like this one. In this particular problem, suppose u and v are functions of x that are differentiable at x equal to 2. We're going to find the derivatives of problems number 1 up until 4, given that u of 2 is 3 and u prime of 2 is -4, and so on. So to apply the derivative rules, we're just going to be working on its notation, and let's try it out with our first problem right here, which is to find the derivative of uv in terms of x. So we have uv right here, and we know that we're going to be using the product rule in finding the derivative of uv. So we're just going to be working on the product of these two right here. So the derivative would be u multiplied by v prime plus u prime times v. So that is my product rule for u and v, and I need to evaluate it in terms of x equal to 2. And these are the values that I'm going to be using for each of my variable right here. So u of 2 is 3, v prime is 2, added to u prime, which is -4, and v prime, or v, is equal to 1. So you just ignore the number inside the parentheses and focus on the values of each function. So we'll have 6 plus -4, which is simply 6 minus 4, which will give us 2. So the derivative of uv as x, or at x equal to 2, given this information, will simply be 2. Now let's answer problem number 2. So in problem number 2, we're seeing fractions. So when we see fractions, we know that we're going to be using the quotient rule. So for number 2, to find u over v prime, we're going to be using the quotient rule. And we know that the quotient rule is simply low d high minus high d low all over low squared. Low means the denominator and high means the numerator. So to use that to find our u over v prime, it's simply v times derivative of high, which is u prime, minus high, which is u, times the derivative of low, which is v prime, all over v quantity squared. So this is the derivative of u over v, but we need to evaluate it in terms of x equal to 2. So using these values over here, we'll be able to complete our work. So v is 1, u prime is -4, minus u, which is 3, and v prime, which is 2, all over v, which is 1, quantity squared. So with this, we'll have -4 minus 6 all over 1. And -4 minus 6 is simply -10. So this will be our second derivative, the derivative on the second problem, given this information. Now let's see how it differs from problem number 3. For problem number 3, it's still the same thing. We're just going to find the derivative of v over u this time. And notice that the notations are different. So the key here is understanding the notation that we used in calculus to be able to answer simple problem like this. So for number 3, we're finding the derivative of v over u in terms of x. And we're going to be using the quotient rule again. So the quotient rule, we already know that from our previous example. So v u derivative would be low d high minus high d low all over low squared. So now that we have the derivative, we're evaluating it at x equal to 2. So by substitution, u is 3, v prime is 2, v is 1, u prime is negative 4, all over u, which is 3 squared. And by simplifying our fraction, we'll have 6 plus 4 all over 9, which is going to give us 10 all over 9. So that's our derivative for our second problem. And for the last problem, we have 3u minus 2v plus uv, and we're going to find its derivative using the derivative rule. So we have three functions here: 3u, 2v plus uv, and we're going to take its derivative. Now, we know that this 2 right here is just the derivative of u, which is u prime and v prime, but this one, we will be using the product rule to simplify or to differentiate uv. So let's go ahead and take the derivative of this function, which is problem number 4. So we have 3 times the derivative of u, which is u prime, minus 2 times the derivative of v, which is v prime, plus the product rule of uv. So u prime times v plus u times v prime. So notice that this time I took the derivative of first and copy second, because in product rule it doesn't really matter which one you take the derivative on, because it's addition, so they're commutative, so they can interchange and you will still get the same result. So now we're going to evaluate it at x equal to 2. So just like what we did on the 3 other problems, we're going to distribute the values of these function from the given information. So 3 times u prime, which is negative 4, minus 2 times v prime, which is 2, added to the quantity of u prime, which is negative 4, v, which is 1, plus u, which is 3, and v prime, which is 2. So we'll have negative 12 minus 4 plus the quantity of negative 4 plus 6, which will give us negative 4 plus 6 is 2. So from negative 12 minus 4, so we add 4. So this one is negative 16. Add it to 2. So it's equal to negative 14. So the derivative of the last problem is simply negative 14.